Today I'm going to tackle some shop organization I've been meaning to do for a while. This wall is not being used to its potential, it's a mess, and the lack of organization definitely slows down my workflow. So I'm finally going to build custom cabinetry here that fits my space and my needs to hopefully improve my productivity. I drew up a quick sketch in SketchUp to make sure I got the layout okay, like making sure I still had access to remove my dust collection filter and it fit with everything else I already have going on in my shop. Then it was off to Home Depot to buy some plywood. It must have been my lucky day and I actually found not one, but two guys who helped me out at the panel saw. I don't have a truck, so I have to get all my plywood ripped down in order to bring it home. Planning a project can be a bit overwhelming when trying to figure out how much material you need to buy and how to cut all those pieces, especially when it comes to sheet goods. I used to painstakingly plan my cut lists in SketchUp piece by piece, but then I discovered a couple of websites that do it for you in seconds. This material is only going to be used for the main cabinet boxes, and I just got the least expensive 3/4 inch ply that they had in stock. It's not the best, but this is a shop project after all. When I got the plywood ripped at Home Depot, I told them to cut it like a 1/2 inch bigger than what I actually needed so I can rip the pieces to final width in my shop and the edges will actually have a nice clean cut. Honestly, even if I did have a truck, I would still get my plywood ripped down. It would be really difficult for me to lift a full sheet by myself. I even need this roller behind the saw to help support these already cut down pieces. Moving on to cross-cutting these into panels that will make up the cabinet boxes. The first step is to make one end square. Chances are, after ripping the boards to width, the factory edge that's adjacent to the cuts you made will not be square. One pass with a track saw, and we're good to go. I chose the track saw to break this all down, and it was a pain in the tuchus to set up each cut to make sure it was square and the right length. I totally understand MFT tables now, and I really want to build one. After each cut, I would check off the corresponding pieces on my cut list and move on. These boxes will be made up of a bottom, 2 sides, and 4 stretchers. So I cut all the stretchers with whatever material was left over after cutting the larger pieces and made sure to label each piece. That's probably the most important step. So here's what the box is going to look like. Besides for all this 3/4 inch ply I just milled up, there's going to be a 1/4 inch back panel that will slide inside grooves that are cut into the sides and bottom. 1/4 inch panels are never actually a 1/4 inch, so I'll just have to make that groove in 2 passes at the table saw. The panel will need to slide in front of one of the 3/4 inch stretchers that will be on the back of the box. So I used one of those stretchers to set the distance of the fence and set the blade height to cut roughly a 1/4 inch deep. First I take a scrap piece and run it through the saw. That will be my fit tester when I adjust the fence. So I place it off to the side and make that initial cut on all the parts. Both sides and the bottom are getting grooves here. Next, I take the tester piece and nudge the fence ever so slightly away from the blade and test fit that on the 1/4 inch panel. In reality, this took me 3 little nudges to get that perfect fit. Once set, I can run all the sides and the bottoms through to widen the groove. 3 of these cabinets will have a lower half that has doors with an adjustable shelf. I find it's easier to drill the holes for that shelf before assembly, but now that the groove is cut in, I need to make sure I'm drilling those holes in the right place on each side. So I mark all the bottoms with a B, so I can always reference that bottom edge with the jig I'm going to use. There are lots of fancy shelf pin drilling jigs on the market. I'm just going to use a stop collar on a drill with a piece of MDF that I drilled holes through at the drill press. I clamped a spacer board so it's flush with the bottom of the side panel, then placed the shelf pin jig on that spacer, also making sure it's flush with the edge of the panel. I marked on the jig which edges should be facing down and out, so I don't get confused when flipping the jig to the opposite side. This makes sure the spacing will be consistent on both edges. Side note, I'm kind of loving my workbench setup for stuff like this. I love having the holes for holdfasts and also being able to easily clamp around on all the edges. Also, this is where labeling your parts is super important. I had a total of 12 side panels, but only 3 cabinets are getting these adjustable shelves. All right, time to assemble the boxes. First, I'm just tacking the parts together with brad nails. I start with the bottom piece down on the table, then I tack one side, making sure the grooves are oriented in the correct position, then the opposite side, again being aware of the side the groove is on. While it's still upright, I tack the bottom nailer strip in place, then I flip the box onto its backside and put the top nailer strip in place. Those two strips will be used to secure the cabinet to the wall. Next goes the back stretcher, and I put a 1/4 inch scrap spacer on top of the nailer strip to make sure I'm leaving enough room for the 1/4 inch panel that will slide in later. Finally, the front stretcher goes on, and I find it easier to flip the cabinet on its side when securing it with brads. Now just repeat this process 5 more times. Once the cabinets are roughly assembled, I can get an accurate measurement for the back panel, which I ripped down at the table saw, and then cut to size. It was very satisfying to slide all these into place, and you could see here why it was important to use a 1/4 inch spacer when tacking the top back stretcher in place, and also why I used the stretcher itself as my setup guide when cutting in these grooves at the table saw. Don't worry, I am not just relying on those brads to hold all these parts together. Now I'm going to secure everything with screws. I set a marking gauge to half the thickness of the material to mark out all the hole locations. Then I countersink some holes and screw it all together. You may have noticed the exposed plywood edges. I decided I didn't want to waste time edge banding these because it's a shop project. If it wasn't a shop project, I probably would have edge banded before I cross-cut the parts into panels, definitely before I assemble them. Boxes are done, time for some draws. Seeing as this is a shop project, it's perfect for experimenting, and I've never used pre-finished plywood before, so that's what I'll use. Every month, Woodworker Source has a special on some type of wood. Last month when I got these, the special was this plywood, so I stocked up. If you're curious, this month's special is live edge slabs and cookies. I may need to pick some of those up. Anyway, with the Cutlass program I used, it was very easy to break down all these parts. First, I ripped all the panels into strips that determine the height of the draws. Then I can cut the pieces to length. I start with the draw sides first because those are the exact length as I want the draw to be. I cut these on my crosscut sled using a spacer block clamped to the fence so the piece does not bind when I push the sled forward. Sides are cut onto the fronts and backs. If you build draws using simple butt joints, determining this length is easy. Subtract the thickness of both side pieces and both slides from the cabinet opening. But I'm not doing a butt joint. I'm doing a lock rabbet joint. So I need to take the tongue of the rabbet into account when figuring out the length. I did a whole video on how to do this type of joinery for draws using something called the quarter method when I built the draws for my workbench. So I won't go into too much detail, but this time I wanted to see if I can achieve the same results without setting up a dado stack. Instead, I have a single blade and I set up stop blocks so I can adjust the fence to the exact width cut I needed. The side pieces are cut first because they're easier to cut. They simply get a dado cut on both ends. I chose to try out the single blade method as an alternative for anyone who doesn't have a dado stack, and because this plywood was slightly undersized. So if I used my 1/4 inch dado stack with this method, the joints would have been a little loose. After the first pass, I adjust the fence to the other stop block I set up and make the second cut, widening the dado to the exact thickness I need, which is exactly half of the thickness of this material. Again, I have a very detailed video that explains the math behind this whole process that I'll link down below. Next, I cut the rabbets on the fronts and backs. In the video I just mentioned, I held those pieces upright using a clamp on the fence, and I didn't love it. So this time I used a suggestion from some of the commenters on that video. I was able to keep the board flat by using a spacer on the fence, which nudges the workpiece over the correct distance, creating the initial cut of the rabbet. Then I just had to do one small little pass to remove the rest of the material on the edge, and voila, perfectly sized rabbets while still keeping the boards flat. Thanks, guys. Last step in this process is to cut all the grooves that will hold the bottom 1/4 inch panels. It's important to be aware of the correct side you're cutting on. The sides get a groove cut on the same face as the dados that I cut, but the fronts and backs get a groove cut on the opposite face as the rabbets that were cut. Again, I'm doing the same single blade adjust fence to widen cut technique to make these grooves to fit a 1/4 inch panel. Cutting all those dados, rabbets, and grooves was a lot of work, but we are not done yet. The bottoms all get cut to size based on the joinery cut into the draw parts, and this is a new thing I decided I'm going to do from now on. Sand all the edges to ease all the sharp corners, which will help them slide a bit easier during assembly, which is the next step. The joinery cut into all these pieces makes assembling these a breeze. I put glue in the dados cut into the sides, put the bottom into place, and then assemble all the draw parts around the plywood bottom. You only need 2 clamps to hold this together, but I'm building 19 draws and I don't have 38 of these clamps. So I shoot a couple of brads through the fronts, making sure they go through the tongue, which will hold it in place while the glue dries, and repeat 18 more times. While I'm assembling these draws, I want to tell you about my new favorite toy, the Bambu Lab A1 Combo. This is an entry-level 3D printer that is crazy user-friendly, making it possible for anyone, even non-techie, geeky people like me, to start 3D printing at home. It took me about a half hour to assemble the machine, and I was able to start printing right away because there's one-click printing from MakerWorld. MakerWorld is a user-driven website where people upload their own designs and anyone can download them and start printing. You can scroll through MakerWorld on a computer or the Bambu Handy app. Focused on shop storage, I found these battery holders, and all I have to do is click Open in Bambu Studio, then the file loads into what's called a slicer. You do not need to know what a slicer does or doesn't do to get started. Simply press slice and the program creates the file to send to your 3D printer. There's lots of data here that I do not fully understand, but one thing to notice, the cost. This battery tool holder will cost less than $3 to make. Next, click print, and a couple hours later, you have a useful object that was literally printed out of thin air. Now, this is a super high-end machine. Bambu is known for their superb print quality and speed, but I bet you'll be shocked by the price. Not only is this machine affordable to help you get started with 3D printing, it's also the only system you can get in this price range that can print more than one color at a time. Check out the link down below to learn more, and huge thanks to Bambu Lab for sponsoring this video. I'm going to show you guys some more useful items I make with it later on when I start to organize everything. Draws are done so I can prepare for the install. You may have noticed that I did not build an integrated toe kick into the cabinet boxes. I thought it would be easier to build a square box with a separate toe kick, so that's what I'll do now. I cut some spacer blocks that will act as ribs that support the cabinets. I have actually never built cabinets this way before, so you're watching me experiment. I don't know if this was a good way to build a toe kick or not, but this is what I did. I marked a center line on all the pieces that I'll use for alignment later, then began assembling the ribs. I doubled up the plywood, creating a thicker support that will go under each cabinet box side. Then I tacked pieces onto the ends of that, creating this eye shape. I was able to use the center line I marked out to make sure it was centered between the 2 glued up boards. For the ends of the toe kick, I made a piece that looks more like a C shape. Then I attached all those assemblies to the plywood board I ripped earlier with glue and brads. I am not putting a panel on top of this to cover it up like what you would do in a kitchen, because shop project. So I wanted to nail it from the inside so you don't see any nail holes from the front. Those center lines I drew on the blocks in the first step really came in handy when placing these down. I made sure to measure where the cabinets are going to lie so they will have the most support possible. The span of all these cabinets together is around 135 inches, so I needed to make 2 of these toe kicks. I thought maybe it would be cool to use one of those eye pieces to join them together, so on this one, the eye is hanging over the edge, and on the second one, I left an opening that will fit over the eye when I install it. But before I could do that, I need to clear this place out. This corner was such a mess, and it's been severely underutilized for the past 2 years. All cleaned up, I put both of the toe kicks in place, and you can see how the open end of the second one fits right over the eye of the first one. I clamped them together, then secured them with screws, and I could begin the leveling process, which was really annoying. But leveling a bunch of separate boxes would have been even more annoying. Once level, I screwed it to the existing trim and marked all the stud locations on the wall before putting the cabinets in place. You can see how each side panel of each box is resting on one of those cross beams in the Toekick due to my layout lines. This is gonna be awesome. Since I spent time leveling the Toekick, the boxes should be level and I can simply attach them together with screws. Now that they're all one unit, I secured the whole assembly to the wall with screws that go through the nailer strip into the studs I marked out. The moment I've been dreading this whole build. Draw installation time. I was following the drawing I made on SketchUp throughout this whole build. So I used the drawing to mark out where the bottom of each drawer should end up on the edge of the cabinet. Then I marked a second line to indicate where I want the drawer slides to be installed. Last time I made a drawer installation video, some people got a little upset I used a piece of scrap wood that was a little too pretty. So I found the scrappiest scrap piece I could find and lined it up in the cabinet to transfer the slide placement line onto the edge and cut it to size. When the slide is placed on top of the scrap inside the cabinet, you can see that the bottom of the slide lines up with the second mark I made. That's where I want it, so I secure it in place with screws. The beauty of using the scrap method is that you know both slides will be perfectly even with each other since the scrap piece is resting on the bottom of the cabinet. I secured the opposite slide in place, then you use that same scrap to install the upper slides in all the cabinets. Now I move down to the next line marked on the tape, cut it to size, and install those slides. To ensure the slides are flush with the front of the cabinet, I use another small scrap butt up against the edge when lining it up. I know most of you guys watching probably aren't little girls like me, but I gotta say, getting inside the cabinet to install these slides is the way. Because I started from the top down, I just kept cutting that scrap into smaller and smaller pieces until I got to the bottom and installed all 38 slides. Now I install the drawers from the bottom up using scraps as spacers as well. I usually leave a 1/4 inch space for the bottom drawer so I can use a 1/4 inch piece of plywood to hold it up and screw the slide to the drawer, making sure the front is flush with the front of the drawer. For now, each drawer gets 2 screws per side, but later I'll take them all out and add a 3rd screw to secure it a bit better. I continue installing all the bottom drawers and run into a bit of a problem with the cabinet that's against the wall. I can't fit my drill in there to lock it in place, even with a 90-degree attachment. So I leave the spacer underneath it and I'll tackle the other side of all those drawers after they're all installed. Getting the size of the spacers for the next drawer is easy. I already marked the bottom of each drawer on that piece of green tape. So I measure from the top of the bottom drawer to that line and cut a couple of pieces at the table saw to that width. Stack those on top of the already installed drawer and lock it into place. Rinse and repeat in the next cabinet and then move on to the next one until you get to the top. Here I ran into a bit of an issue. The drawer wouldn't fit for some reason. It was too tall. Then I looked at my SketchUp drawing, and I'm not quite sure how I missed this, but the top drawer in my sketch is actually colliding with the stretcher in the sketch. Slight oversight on my part, but no big deal. Everything is fixable. I was actually a little nervous to make this cut, but I've cut lids off of boxes before, and it's the same concept. I did have one of those brads I used to secure them fly at me though, so I was glad I was wearing my safety glasses. All right. Now this shorter drawer fits into the space and I can focus on figuring out how to attach the rails on all the drawers that were near the wall. Maybe there's a better way to do this, but I just used a combo square to get the correct height on one side, then brought it over to the other side and locked it in place, making sure it was flush with the front. That seemed to work out okay, so I finished those up and moved on to the drawers that will have the cabinet underneath them. I used scrap 2x4s to get the bottom one to the correct height, and then the regular spacers to finish off the top ones. And there is no better feeling than being able to open and close all the drawers you just installed. For the drawer faces, I decided to get a little fancy. I ordered maple plywood from Woodworker Source so it would match my maple workbench. This plywood was not on sale, so this was the big splurge. Totally worth it. First, I ripped the panels into strips that were the height I needed for the drawer faces, then cut them to width using the stop block clamped on the fence trick again with my crosscut sled. The door panels are also made out of this material, and after cutting them, I realized something was off. Shoot. How did I do that? Ugh. I got the grain all turned around and I cut one of the doors too short. First, I panicked because I didn't have any more material and I was looking into how quickly I can get a new sheet. Then I calmed down and remembered everything is fixable. I was lucky this cut was along the grain instead of across it, so I was able to domino a small piece to add to the length. Out of the clamps, like it never even happened. Crisis averted, time to install all this pretty maple ply. I marked the fronts of all the drawers so I could pre-drill some holes and started with the bottom drawer. I put a scrap under the cabinet and shimmed it up so it was flush with the bottom. Rested the first drawer face on it, then clamped it in place and locked it down with screws through the holes I drilled out in the previous step. I ripped some 1/8" strips to add as spacers for the next face, and I really wish that I already had the Bambu 3D printer at this point because I would have had more accurate shims. After checking, this shim was not actually an 1/8" all around. And even when I do make these shims, I end up losing them in the scrap pile and I always have to make new ones. So for future projects, I found this file on MakerWorld and printed them out. I love that there's already so many useful files that I don't need to create my own, but it's also so cool that you can alter existing designs. I decided I wanted more of these 16th and 1/8" strips for this type of installation, so I brought the file into Bambu Studio and just changed the scale to elongate them, and boom, I have super precise shims for my next project that are clearly labeled and won't get lost in the scrap bin. When it comes to the top drawer, you can't clamp the face on when the drawer is closed because of the cabinet stretcher. So I simply open the drawer below it and repeat the process with the shims while they're both open onto the cabinet doors. This hardware usually has 3 ways that you can adjust them. So before installing, I make sure all those adjustment screws are set to the centermost position, so it gives you the largest range of motion in both directions. To drill the holes in the doors, I use the Craig hinge jig. It's a specialty item that only does one thing, but I can never decipher the instructions that come with these hinges, so this thing is a lifesaver. When installing the hinges onto the door, I use a straight edge along the back side of both hinges to make sure they're square and screw them into place. The instructions may be confusing, but it was pretty clear on the setback location for the screws inside the cabinet, so I marked out that line. Same as the drawer faces, I put a block of wood right under the cabinet to hold the door at the correct height. Then use that line I just drew out as a guide for where to screw in the hardware. Repeat for all the other doors, adjust them so the gaps are all even, and then install the drawer faces that go above those cabinets using the shims. In my haste to try and get this project done as quickly as possible so I can move on to more fun projects, I made a few mistakes. So now I'll fix them. On my plan, this cabinet was supposed to be built with a fixed shelf for a compartment that will go above here. No problem. I used 2x4s to hold it up to the height I needed and pocket hole screws to lock it in place. Next problem, this compartment. The plan was always that this top would slide open so I can access it. But in my plan, I meant to leave out the top stretchers that run across the cabinet so I can install drawer slides on top of pieces that run along the cabinet. I thought about removing the stretchers to do this, but wasn't in the mood to deal with that. So just went with what I already built and installed drawer slides to these sides. Then I built this 3-sided drawer that I screwed onto the slides, and I'll come back to that compartment after I install the top. I promise it'll make sense in a bit. The last oversight I needed to fix, I didn't take the thickness of the back of the drawer hardware into account, and the top drawers did not fully close because the stretcher was in the way. Easy fix, I made a quick 3-piece template, double stick taped it to the cabinet, and cleared out some material using a flush trim bit. That created a recess, making room for the back of the hardware, which I then installed on all the drawers. For the top, I'm going to use a panel that my contractor left in my garage. I really hope he didn't need it because I'll be cutting it up. I couldn't lift it onto my workbench by myself though, so I did some other tasks while I waited for my muscle to come home. You may have noticed the exposed screws on the sides of the cabinet. I'll cover them up with plugs that I made from scrap maple and a plug cutter at the drill press. You could snap these plugs out of the holes, but it's so much more fun to watch them pop out at the bandsaw. I glued them in, flush cut them, and then my muscle came home to help me lift the top. He laughed at me because he didn't think it was actually that heavy. If I didn't get this free panel to use for the top though, I would have just made the top the same way I made the top for my workbench and my outfeed table. It's just Formica laminated to MDF. Then I chopped it up into smaller pieces to fit the sections of the cabinets. I promise I'll get to that compartment in a bit, but first I have to add some edge banding. Super fancy again, I'm going with walnut, but I didn't have enough scraps that were long enough to cover the whole front, so I did a little trick to make it seem like I did. I ripped the longest scrap I had in half, then when I flip those two pieces end for end, the grain lines will match up a little bit better. But a straight line across it will make it very obvious, so I cut the widest angle my miter saw could possibly go on both ends of both pieces. And now, when those two pieces go together, the seam is a little less obvious because of the angle. This is called a scarf joint, by the way. All the trim is ready to be glued onto the edge, and I found it easier to place tape under the panel before adding glue to the trim. I could get it in position, then pull the tape over to temporarily secure it, then nail it in place. This was the build that finally convinced me to upgrade from the Ryobi brad nailer. For the scarf joint, I made sure to add glue on the end grain and to shoot a nail through the tips of both pieces. This is a 23 gauge pin nailer as opposed to the Ryobi, which was an 18 gauge brad nailer. So the holes are a lot smaller, but they still need to be filled. I'm really impressed with this good filler. It matches the walnut perfectly. Finally, I'm going to address the sliding compartment. I put some draw slide tape on the top of the cabinet, then used an 1/8 inch shim to get that perfect height for a draw face that will sit on top. That face gets attached to the top with pocket hole screws from the inside. Then that assembly gets placed on top of the cabinet and clamped to the 3-sided draw I installed earlier while I screw it from the inside to secure all the parts together. Now you can see how this is just a compartment that opens from the top because I didn't want to waste all that valuable space that the workstation for the Shaper Origin will be blocking. The compartment was left open to assist with assembling this top, so I closed it off with a piece of plywood that just gets nailed into place through the stretcher on top and the shelf underneath. Now nothing in this compartment will fall out of the front. I screwed the top to the cabinets through the stretchers, then added a couple coats of finish to the whole unit, and I think that scarf joint on the trim came out pretty nice. A pretty decent grain match, if you ask me. Last thing to do, install the adjustable shelves, and it's time to get this shop back in order. This whole sliding compartment section is for the Shaper Origin workstation. The apron on the front of it prevents any access to the cabinet, so making this whole top slide was the best way to not waste that space. I can store all of my Origin accessories in there, and it's easy to open and close once the station was attached. Figuring out where and how I was going to store everything else was fun. Some drawers just get loaded as is. I prefer to keep my screws in the boxes they come in, but for others, I created these custom bins in Fusion 360 that I could print on my Bambu Lab A1 printer. I am not proficient at Fusion 360 at all, and I was able to easily print these and some other designs that I'll use for storage in these drawers. I didn't like how the AMS was sitting on my Shaper station, so I found this AMS bracket on MakerWorld that screws onto the wall, and now this whole section back here looks nice and neat. I hung the battery holders that I 3D printed on the wall, and I think this setup is great. I was also able to find some files on MakerWorld to hold some of my drills and their accessories on my wall control pegboard. There are so many pegboard storage files on there, it's awesome. I'm really happy with how I set up the cabinets. I love how there are 2 rows of the smaller drawers because most of the items we use as woodworkers are small, flatter items like squares, chisels, tape measures, and router bits. Believe it or not, I've been storing all of my router bits in this Ziploc bag for the past 7 or 8 years. I know. Off to MakerWorld I went and found this router bit storage file to print. This is 1,000 times better than a Ziploc bag, and it's so cool that there are so many awesome designs already out there to print. I've only just begun organizing these cabinets. This is definitely going to be a work in progress that I'm going to keep upgrading as I use this space. I'm even happy with how the sliding compartment turned out, even though this is not how I intended to build it. This space is no longer wasted, and the countertop remains flush through its length because I shortened the cabinet. Overall, I am thrilled with how these cabinets turned out. And I know having them is definitely going to improve my productivity, but I'm still not done with this wall. I still want to add shelves over here, and I want to put a lumber rack on top of there. And something that I didn't address with you guys was the cabinet depth. Standard cabinet depth is 24 inches, but I went with 18 because I'm short, and having a narrower base, it makes it easier for me to reach the top of my pegboard and the future shelves that I'm going to put up there. That was a sacrifice that I was willing to make. As I was organizing, I found a bunch of these integrated draw handle templates from previous projects. And it looks like I even made the same shape and size twice because I probably forgot I had the first one. So I quickly came up with a more permanent design. It needs some tweaks, but look how amazing these multicolor prints come out. I can't get over how cool this lettering looks. I've only had this 3D printer for not even a week before it gave me that inspiration to design that jig, so I can't wait to start thinking about more 3D printed jigs to create for my shop and yours as well. I've already printed so many useful accessories like these clamping bridges that you can buy a 12-pack for 60 bucks or print them at around 20 cents each. And this drilling guide that allows you to drill on dowels and the center finding jig. Seriously, so fun. Thank you so much to Bambu Lab. And now I have a place to store all the amazing things that I'm going to print. So I actually wasn't going to make this video because I personally don't think building cabinets is interesting. I just wanted to quickly slop this together so I could move on and focus with what I actually love to do, which is designing and building furniture. Some of my other content creator woodworking friends convinced me that other people don't find cabinet building boring. So I hope I was able to make this simple shop upgrade interesting, educational, and enjoyable to watch. Thank you so much for watching, and I'll see you on the next one. So happy. I hate sweaters, and nobody's home. You can do this. I got it. I got it. I got it. I got it.